his commitment to the advancement of technology and science. His impressive body of work includes 67 publications in Scopus Index Journals and 46 conference proceedings, showcasing his contribution to the field. With a research focus on data mining, machine learning, pattern recognition, and medical imaging, Dr. Agarwal has made significant strides in these areas. So, everyone, have a great round of applause for Dr. Agarwal.
Thank you for the nice introduction. Okay. Am I audible to all of you? So I think in the last 2 days, you have learned basics of deep learning. Okay. And primarily you may have talked about convolutional neural network. It's fine. So you have done neural network, you have done convolutional neural network. But today we are going to talk about RNN and LSTM. That is recurrent neural network. Okay. So question is how this is different from your neural network or convolutional neural network, or what kind of problems you are going to use this RNN architecture or LSTM architecture. So basically both these are used for the same purpose, but RNN has some disadvantages. I'll be talking about that what are the disadvantages of RNN, and then how LSTM helps you to solve that problem. Okay. Now, when you talk about neural network, I think what you may have learned, that is you have input layer, then you have one or more hidden layers, and then you have one output. Okay. So assuming that you have the number of nodes at the input layer, and at present I'm assuming that you have only one hidden layer. So you think about that you have k number of nodes at the hidden layer and c number of nodes at the output. Every node of input layer is connected with every node of hidden layer. And then every node of hidden layer is connected with every node of output. Assuming that you have ith node, I think this is not working. Yes, actually the screen is not. Okay, no problem. No problem. Okay. So assuming that this is the ith node at the input layer and jth node at the hidden layer, you assume that there is a weight between these two nodes. This is given by Wji. And similarly, assuming that this is your kth node at the output layer, you are connecting this jth node with kth node with the weight that is Wk. Now, assuming that you have each sample is represented in terms of D features, point to be noted. Each sample is represented in terms of D features. And if you are solving, let's say, 5-class problem, okay, you want to recognize A, E, I, O, U. So it is 5-class. So you are going to have 5 nodes at the output. You are solving 10-class problem, say 0 to 9 numbers you want to recognize. Then how many nodes you are going to have output there? If you are going to differentiate, let's say 100 types of samples, then how many nodes at the output there? So let's say you are going to follow such kind of representation. Okay. So you initially you are given a training samples. You don't know what are these weights. What you do? You start with the random weights, and then you pass the sample. Let's say the input is given by say x1, x2, x3, xd. You want to find out what is the net input reaching to this node, jth node. So how you compute? wj1 x1 wj2 into x2 plus wj3 into x3 plus wjd into xd plus some bias. Okay, let's say wj0. So this is the net input reaching to this neuron. So you have, there is some input to the neuron, and I'm saying this neuron will process. So after processing, it has to give some output. Okay. So how you find out what will be the output? So you think about that. Okay, you are going to model this with the help of some kind of activation function. So you can use different kind of activation function. So you may have heard of sigmoid function, ReLU function, LU function, sine function. Okay, so you have different kind of functions. So I assume that this is the net input. The net input which is reaching to this neuron, jth neuron, is, I use the notation net j. So output of this jth node, I am saying it is given by yj. And this yj is nothing but depending upon what kind of activation function you are using, you can compute f of net j. Is it fine? Now you have output at these neurons, hidden layer, y1, y2, y3, yj. So all these are going as an input to this each one of this node. How you compute the input to this neuron? Y1 into yk1 plus y2 into yk2 plus yn into yk okay, yk and plus some bias. So let's say this is nothing but net of k. So what is the output? So again, it depends upon what is the kind of output you, which function you are using. I can use any function. I can use g of net. It is a different function. I can use different kind of activation function at every neuron. No one stops me. Okay, but usually at same layer, I use one kind of activation function to make our task simpler. So that doing coding is easier. Okay. So you use one kind of activation function. I can use the same activation function, can also be used at other layers also. But at present, I am assuming that what is this activation function? F. Okay. So what is the output at these nodes? Zk will be given by f of net k, where I am saying output observed at this kth node is z of k. So you are giving the input, you are observing the output, that is your z1, z2, z3, zk. But you want that the output should be t1, t2, t3, t. So if your z vector is different from t vector, then you have to change the weights. You have to change the weights. Okay, it means the weights which you have used for initialization is not good enough to classify the given input sample. So you are going to change, and I think you must have learned how you can change these weights. So you are saying that you can compute what is the net error at the output layer, and the whole objective is that I should be able to minimize this error, minimize this loss. Okay. And what is the best way of computing? So in mathematics, all of you may have learned one quantity which we say gradient of some scalar function. So you know what is error? You compute gradient of error. So gradient of error is a vector quantity. Remember this. Gradient of error is a vector quantity. Vector means what? It has magnitude. It has direction. So what is the meaning of gradient of error? If you go through the actual meaning of gradient of error, it tells you a vector along which if you move, error will increase. What is gradient of error? Gradient of error is a vector along which if you move, error will increase. But what is your objective? Are you interested in increasing the error? No. You want to decrease the error. So what you will do? You just move opposite of that direction. So then what is your delta W? If you want to change some weight W, then delta W is given by minus of del error by del W. Then what is the role of this eta? Eta tells you this minus del J by del W is telling you along which direction I should move. But it is not telling you by how much I should move. Okay. So it is estimation. Estimation may be correct, estimation may be wrong. So at initially, your estimation may not be correct. But with time, you keep on improving your estimation. So what is suggested that eta, initially, if you choose, you move along this direction, but that can take values between 0 to 1. What do you mean by 0 to 1? Same magnitude, or eta will what you do? Reduce. So I am saying 0.1 means I am moving in that direction only 0.1 times of that magnitude. Is it fine? Okay. This is very important. I am again stressing, okay, because if you can understand these basic things, understanding any deep learning algorithms will not be difficult. So I am re-stressing this particular fact. That's why I am revisiting this part which you may have already done. Okay. So, what is delta W? Delta W is telling you by how much you should change the weight. Okay. And your eta is controlling by how much you are going to change. And in general, we take eta to be between 0 to 1. Initially, I take eta to be large. Large means around 0.2, 0.3, 0.1. Okay. But which time I keep on decreasing by. Okay. All right. So, I think I will not discuss the derivation part. So, you may have learned this. Now, we are going to talk about RNN. We have already learned neural network architecture. So, why RNN? In artificial neural network, point to be noted, what is important point, what kind of problems you can solve. You can solve classification problem, you can solve regression problem. You can solve classification problem, you can solve regression problem. But what is the kind of data you should have? Labeled, okay, fine. Or regression means your regress value will be there. What else? What? No, no. It should be labeled data because you are talking about supervised learning. What is the important point? The size of means the dimension of your key samples should be fixed, is same. Means your each sample is represented in terms of same size. 10 dimensional, 20 dimensional, 15 dimensional, 1000 dimensional, 2000 dimensional. Every sample of training data should be of same size. But in general, you have many problems where the dimension of the data may be, and let's see some of these problems. Somebody has tweet. Okay, he has used certain set of words by tweeting, and now based on that tweet, you have to tell whether it is a positive sentiment or negative sentiment. You may react corresponding to one policy of government of India. You are also reacting, you are also reacting, you are also reacting. But while you are typing, okay, the number of words used by you can be different from the number of words used by you or by you. Yes or no? So it is not of the same size. So even though this is a classification problem, you are saying it is a positive sentiment or negative sentiment, or you say neutral sentiment, but the sample is not described by fixed size. Dimension is not fixed. So how you can solve this problem? Okay. Second thing, let's see. Let's say on base of your voice, how you are speaking, how you are speaking. So I can find out whether you are in under depression or not. So you are speaking, you can keep on speaking. You may have spoken only 10 sentences. This person may have spoken only one sentence. The other person may have spoken 20 sentences. Okay. And but now, after hearing those sentences, I have to figure out whether the person is in depression or not depression. Classification problem. Or I want to see stage of depression. Stage 1, stage 2, stage 3. Now, let's take another example. You have an image. I show you image, and now you have to tell what is happening in this image. So same image you can describe by 5 sentences, you can describe by 2 sentences. Or the two different images of the same size, one image can be described by 20 words, other image can be described by 15 words. Okay. Image size can also be different. So I'm saying that the size of the input data can be different, the size of the output can be also be. I'm saying I eat mango. I'm specifying. I'm typing about I eat sweet mango. Okay. I go. I eat sweet mango, which is yellow in color. Or I can say somewhere else. So can you see that I'm describing something. So this sentence can be of 2 words, or it can be 3 words, or it can be 5 words, or it can be 10 words. All of us use Google Baba. Okay. Without that, I think nothing can happen. Today also, when I was coming from Dwarka, I was thinking how I should reach, so I used take help of Google Baba. So many times I use Google Baba, so I start typing. I started writing India. Okay, it suggests you many different options. Okay, so because corresponding to India, many information is there. So then, but I'm interested what has happened between match, which is yesterday there was a match between India versus women's match, women's cricket match. So India versus I have written UAE. So again, it's suggesting certain options. Okay, women's cricket, 2024, 2023. So what I'm talking about. So you have multiple set of options. So you want to develop such kind of system, which allows user to choose one of this. Can I solve such kind of problem with the help of this artificial neural network? You don't have fixed size. You don't have fixed size. So you will see we can solve such kind of problem with the help of reference neural. So I'm saying not all problems can be converted into one with fixed length inputs or fixed length output. So when you have such kind of problem, then in that case, so let us take one simple problem. You are giving some binary numbers, which is consist of zeros and ones. And my question is that the number of ones, if this is even, the output should be 1. the number of ones is the binary string is even, then the output should be 1, else the output should be 0. So am I defining what should be the length of the binary string? So can I solve this problem? This is a classification problem. If I use artificial neural network, the number of nodes at the output layer will be how much? 2. But what about number of nodes at the input layer? I don't know. Because you can have your binary string of length 2. It can be binary string of length 5, 7, 9, 11, 13, 15, 20. It can be anything. So if I have to solve, so you find that artificial neural network will not be able to give you the solution. Okay. So what we do, so I think I will explain with the help of this example. So I consider every input at a particular time. So when I say I eat, so there are only two words. So I is the event at t is equal to 1, and eat is the event at t is equal to. So in this case, my x1 is representing the input. So at t is equal to 1, I have given the input. So now you are going to be in state h1. And now at that state, what is the output? So I am saying output I'll be observing is 1. Okay. But now, so you just think I am typing I. It is going to give you many options. Okay. So now let's say my next input is eat. Okay. So at t is equal to 2. Input is x2. But it also depend upon what is the previous word. Yes or no? Context is important. Okay. So the context is important. So in this case, how I model? So it is going to look into what was the earlier state at t is equal to 1. That will also go as an input to this module. X2 is also an input. Based on these two input, it is going to give output. Now at next stage, what will happen? You will find that S2 will go as an input. X3 is my next input. Based on these, I am going to compute what is the output at t is equal to 3. Okay. So let's say if you have sample of length 3, I can compute what is the output at the various units y1, y2, y3. But in this important architecture, you have to remember this model H has weights which are same. It is going to be shared across the whole architecture. Okay. Means this module will have certain weights which should be same across the whole network. It is going to simply unfold. Okay. But it is going to consider two inputs. One input will be your input, and another is what was the state of last input. Okay. So can I model like this? Can I model like this? So at time t, the input is xt, and for previous input xt minus 1, your state was xt minus 1. Those two will go as an input, and this module has connections depending upon what is the length of xt and what is the length of xt minus 1. Correspondingly, the weight w you have to learn. Okay. So if you have only one xt here and xt minus 1 is also of length 1, then how many weights you are going to have? 2 plus 1 bias. So you have three variables which you have to learn. But if you say that this xt is of length 5 and this your st minus 1 is of length 1 and your bias is 1, so 5 plus 1 plus 1, so 7. So how many weights you have to learn? So depending upon the problem, you are going to have this. And now, so these are the two inputs. You will not be knowing initially weights, just like artificial neural network. You are going to compute what is the net input.
Okay, so net input can be computed. Your you can think about W into xt plus W into xt of st minus 1. This is some you can say scalar variable plus some bias. So now that is your input, and what is the activation function you're using? 10 hyperbolic. So what is the characteristics of 10 hyperbolic function? The output range will be between -1 to 1. While sigmoid function output is range between 0 to 1. Okay. So you can see that at time t, the input is xt, and you are getting your what was the state after the input of xt minus 1. What is the state? St minus 1. This is going as an input, and you are going to have output st. So you can think about this is a recursive architecture. This is a recursive architecture. Depending upon what is the length of the input, if you have on the length of the input is your 5, so then this has to be unfolded how many times? 5 times. If the length of the input is 20, then how many times this has to be unfolded? But this W, which is describing this module, is not known to us. Okay, and we are going to learn from the data. Okay. So you think like this. So at present, I am showing for only when the length of the input is only 3, x1, x2, x3. This is my your W. W will describe this weight. So these two in H naught, initially H naught I consider let's say 1. Okay. So taking this input, can you compute what is the net input going to this activation function? Based on that, can you find out what is the output H1? Now, depending upon H1, so I have modeled ST as this. I think this part is clear. Now, for a given ST, what is the output? So I'm saying again, we're using some kind of activation function, and let's say f of st. So what is the yt you are observing? That is your f of st. Now, as you have done in artificial neural network, for a given set of weights, you have given input. You know what kind of output you want. So that is ground truth. Or target output is already given to you. In supervised learning, for every sample, target output is given to you. Ground truth is available to you. Now, based on this, you will be able to find out what is the amount of error this network is making. So, what is the loss at this point? The loss I can compute. Sorry. What is that? So, can you compute what is the, if your output here you expected is GT1, but you are getting output to be Y1. So, can you compute what is the error? So, error can be also of different kind, whether you are using square error, whether you are using mean absolute error, whether you are using cross entropy error, whether you are using Kullback level divergence error. So, there are different kind of errors. Okay. So, you can compute what is the amount of error at this point. Similarly, you can compute what is the amount of error at this point, and similarly, you can compute what is the amount of error at this point. Okay. So, if you have error, what do you do? You have to change the what I told you. Here in this recurrent neural architecture, this cell, each cell is described by same set of weights. So you are going to update weights at one go. Is it fine? Okay, this is a shared network architecture. So now let us see what kind of problem we can solve. I can classify restaurant review. Okay, and means restaurant review. But so someone is writing only 10 lines, other may be writing only 2 lines, the third person may be writing 20 lines, and now based on the review, you should be able to find out whether it's a positive review about this or negative. Sometimes you want to label between 0 to 5, because in general we see that label is given between 0 to 5. So it's scaled, you can decide. So if you are saying between 0 to 5, then it becomes a regression problem. But if you're talking, you are discretizing 0, 1, 2, 3, 4, then again it's a classification problem. You're saying only 0 and 1, then again it's a classification problem. Now, similarly, you want to talk about review of a given movie. These days, we look into IMDb to find out what kind of movie it is. Okay. Now, so this part I have described. So now let's see how I'm going to solve sentiment classification problem. So about one particular hotel, so somebody is written the food is this. Okay, and ultimately I have to give only one output, and that output is what? Whether the what is the you can say ranking of that restaurant, 0 or 1. Okay, the quality of the food is good or bad. Okay, so here I am not interested in what is the output here. Can you see here? I am interested only in giving this output only. So at present, this output is ignored for this problem. The output here is also ignored. I am interested to compute only one and out. Okay. So for this, what I'll do? So H for from different H, I'll compute some kind of average H. Okay. Or I can compute your sum of H, and that I utilize for finding out error. It's fine because error can be because of each timestamp. So for considering this, what I am doing, I am computing all HIs using this HIs as a sum or average, okay, or median, okay, and then I'll be able to compute my loss function. Now, similarly, let's think about image captioning. So in this image captioning, what how you model? Initially, you are given a image using CNN. What you can do? What you can do? One is you can do classification. You can find out different objects. Okay. You can describe each one of the objects. So once you are able to find out what are the different objects present in this image, then using the context, I can describe what is happening in the. So for image capturing, what is the first part you are going to do? That you given the image, I will do segmentation. Okay. And from using segmentation, I can find out various objects present in the, and then I will find out their neighborhood, and in that, using that context, I will be able to describe what is happening in the image. So let's say I was able to find out 5 such objects. So I'll give these inputs one by. Okay. So I'm going to use this, and then. So if I give this, so I'll be able to, by getting this inputs, I will be in one state, okay, and then I'll be able to describe what will be the output. So I can describe that there is a dog sitting under the, you can say, bed, okay, whatever is the activity. So similarly, all the image can be provided. So what are the different kinds of problems we can solve using this RNN? One, feed forward network. For a given input, you want to have one kind of output. But that we solve using feed forward neural network architecture. But now what we can solve? Single input. Image is a single input, but you are going to have multiple outputs. So single input, multiple output. So the problem, one kind of problem is image capturing. What is another kind of problem we can solve? Multiple input, single. What is example? Sentiment classification. Okay. Or tweet classification. Okay. Then you have multiple input, multiple output. Multiple input, multiple output. You think about a video. What is video? Can you think about you have a set of frames? So each one of them is acting as an image. So you can give various input. So you have multiple input, and then you have to describe what is happening in the video. So multiple input, multiple output. So you can solve such kind of problem using. Then again another problem. Translation from Hindi to English. Okay. So what happens? So you have a sentence which has multiple words, and what is the output? You want to you translate from Hindi to English. That is also multiple words. So you want to convert from multiple input to multiple output. Again, such kind of problems is solved using RNA. Okay. Now, as you have learned in the case of artificial neural network, that initially you don't know what is your weight. Then what you do? You start with some random weights, okay, and then using gradient descent method, you are going to learn those weights. So what you do? Based on initial weights and initial input samples, you are going to compute loss, and your objective will be to minimize the loss, okay, and you use gradient descent method, okay, or some variant of gradient descent method to find out how to update the. So in this architecture also, just like artificial neural network, you have two stages. One is your forward computation, another is your backward computation. In forward computation, what you do? You give the input is flowing from one layer to another layer, and at the end you will be able to compute what is the net output at the output layer. So this is your forward computation. Based on this output, you will be able to compute error. So this computation is computed in what? Forward states. What you do in backward states? You compute the how to change the weights, and that change in the weights is happening in the backward direction. Okay. So similarly, here also we are going to use, first of all, we compute what is the net error using forward computation, and then we are going to use gradient descent method, and we will be updating the weights in the backward direction. Okay. So in this, you are able to compute what is the net error. So by after computing your error, you are going to find out what should be the change in the weights, and that you are going to compute in your backward. So what you are saying? You know what is the loss? W is fixed in all the cells. Okay. So you want to change the weights. So what is the formula you are going to choose? W is equal to W plus delta W. And what is delta W? Minus eta del error by delta W. So you are going to compute this. In this case, my error is represented by. Okay. But C is not directly function of W. You see that C is a function of Y and YGT, ground truth. But Y is a function of HT, and HT is a function of W. So using chain rule, you will be able to compute what is the amount by which you are going to change it. So how you compute delta C by delta W? So this is a function of YGT is fixed, is constant. So you are going to differentiate C with respect to Y, and then you differentiate Y with respect to W. But and here Y is a function of W. Okay. So now it's also possible that initially here there was only one hidden layer. There was only one hidden layer. But you can think about, you can have multiple hidden layers at t is equal to 1, at t is equal to 2. Okay. So now I'm showing the example of that you have two hidden layers. So you have input. This network is described by weight W1. The output is Y1. Now this Y1 is going here, and some input is also coming from the previous time stamp that will be utilized for computing Y2. But weight here is given by what? W2. Now, based on this Y2 and ground truth, you'll be able to compute what is the loss. So how you'll be able to find out weights? You have to change W1 and W2. So W2 will be changed like this, and W1 will be changed like this. But again, C is not a function of W1, C is not a function of W2. Okay. So you have to solve it using chain rule. Okay. So do I need to explain all this? when you are going to have multiple, you see that this is your loss function at time t is equal to 3. So you are going to find out what is the change in your C3 with respect to W. This will also depend upon how your C2 is changing with respect to W. This is also depending upon how C1 is changing upon W. And also it depends upon what is an input coming, because this S3 is taking input of what? S2. And this is here, this is taking an input of H1. So do you think that S3 will be a function of H2 and H1 both? Yes or no? So you find that if you want to compute what is your del CT by del H1, so you find that you have to compute this, yes or no? So you are saying it is a multiplication of many terms. And if each one of these terms is going to be very small, let's say 0.1, each one of these is of order 0.1. And there are such 10 multiplications. So 0.1 into 0.1 into 0.1 into 0.1, what will you get? 10 is to the minus 10. And this 10 is to minus 10 is as good as 0. So this is also going to give a problem of vanishing gradient. Okay. Or you say vanishing explosion. When there will be vanishing explosion? When this term, each one of these term is what? More than 1. Okay. So in the RNN architecture, this is the problem. That if you are going to have, you can say, long set of this time units, in that case, because of changing phenomenon, it will be as good as there is no change here. Okay. And it means there is no learning taking place in this network. Then what is the solution? What is the solution?
Like in the previous one where the change was more, so we used to decrease the learning.
But even then, I'm saying even you are choosing eta to be small, but still the size of this delta W, this function is of order 10 to minus 1. And multiplying many 10 to minus 1 order term can give rise to a very small value. It will vanish. So vanish at this initial. I think this particular part must have been told in deep learning architecture. That was the main problem. Multi-layer perceptron theory was there prior to 2000. And mathematically it was shown, demonstrated, proved that you can have, if you have many hidden layers, the performance will be better than when you have lesser number of, means what is the importance of deep and shallow architecture. So there was one research paper that was there in prior to 2000. That by using deep architecture, you are going to solve problem much easily in comparison to shallow architecture. But still, prior to 2000, none of us were able to use more than 2 hidden layers. Most of the research works were using either 1 hidden layer or 2 hidden layers. And it was because of what? Because of this chaining rule. Because of this vanishing gradient problem. Okay. So, what is the contribution of deep learning after 2000? It was how to remove, how to handle this vanishing gradient problem. Okay. And so, one of the thing you may also have learned in CNN architecture is that what was the term? Can you see? For computing this is your del st is a function of, instead of to differentiate with respect to st minus 1, st minus with respect to st minus 2, st minus with respect to st minus 3, s2 with respect to h1. Okay. So these terms are becoming very, very small. But if I don't make it small, let's say if this quantity is around 1, if it is 1, then after multiplication, what will happen? Let's say all these are 1, 1, 1, 1, 1, or is it some constant? What will happen? Will it be 0? So thinking of this, so we thought of that can we model like this, that st is given as some function of st minus 1 plus f of st. So now if you differentiate st with respect to st minus 1, what you'll get? 1. Okay. And that what you do in ResNet. That what you do in ResNet. Have you done ResNet architecture? ResNet architecture is one of the type of your convolutional neural network architecture. So you'll find that they have also used a skip connection, and with the help of that, they are able to resolve this problem of vanishing. Okay. So just remember this point. Can I model so that my st is behave as some st minus 1 plus f of xt? So if I can model like this, then I'll be able to control my vanishing gradient. And there we have introduced the concept of your LST. One is we are able to resolve this vanishing gradient problem, and there is another important one. What is another important point? See that since our beginning, when we have taken birth until now, we have learned so many things, and we have also forgotten many things. Which things you remember? कौन सी चीजें याद रखते हैं? Which are important to us. So our mind, our brain, neurons, they are very intelligent. They know what to remember, what to forget. Because you have limited memory. And in this limited memory, you cannot keep all the information. So we are able to keep important information. So similarly, in this LSTM architecture, one of the important point is that when you have very long sentences, and you have to conclude from these long sentences, so you have to understand the context, but at the same time, you should know that if there is this distance between the two words is very large, you may lose the context. But if they are important, then you must remember. So in what way I should be able to bring this part in my architecture so that I should know which part to forget and which part to remember. Okay. And see how beautifully in this architecture this has been suggested. These two things. Okay. So see, this is my, I think all of us use metro. You must have seen your conveyor belt. Many times this conveyor belt is also used in industry, where at different moment of a different time, a different kind of input is placed on conveyor belt, and then it is mixed, and then you prepare some new. So while you are doing things, so let's say it is started, conveyor belt has started from here at t is equal to 1. You have put something, it has done some processing, it has removed certain things, and then you're putting something else, using this to moving further at t is equal to 2, doing some processing, again you eliminate certain things, you bring certain things, and you do again some processing. फैक्ट्री में ही तो होता है, जो बॉटल पैक आपको चीज मिलती है ऐसी मिलती है क्या? Okay, so there is a assembly line is being created. So I'm going to present that part. So at present I'm thinking about at time t minus 1, the output of the stage was given by st minus 1. You have xt is the input at time t. This is your weight of this cell. Now I want to know what is the net content you are getting. Okay, what is the net content you are getting, and now this content will be going through this activation function, and this will give you my output st. Okay, so what you are thinking about, what is my ct? My ct is a function of ct minus 1 plus your 10 hyperbolic w xt of st minus 1, because st minus 1 w, you are going to compute this. So this is the net input coming, What is your CT? CT will be computed in terms of what was earlier content at t minus 1. So you are going to have this. And what is your ST? ST will be depending on what is the content at time t. So see, so when I differentiate this CT with respect to CT minus 1, what will happen? This will become 1. So this will be able to take care of overflowing drop, okay, or vanishing gradient drop. Now, I told you that in this architecture we should be able to have certain things where we should know what to remember, what to forget, what to bring new information, so that we arrive at new content. Okay, and for this, I think that you think about, you have many cells. Each one of the cell has this kind of architecture. Now I'm trying to explain each one of this. How you are able to bring the concept of forgetting certain things, bringing new information, computing new things, how you are able to bring this with the help of architecture LST. So every cell A in your RNA was of fixed kind, that you can hyperbolic W of your XT into ST minus 1. Yes or no? So W was explaining that step. In this case, you have many weights. So each weight will be doing a specific job. One kind of weight will be doing the job of what to remember, what to forget. One kind of weight will do the job of what to bring, okay, and then how to compute new information which are relevant corresponding to the given problem. So you think about, this is a kind of belt, conveyor belt. So at time t minus 1, the conveyor belt was having this content. After t, the conveyor belt will have information CT. At this, it will be your CT plus 1. So this conveyor belt is moving, and which time this information is keep on changing. And how you are able to change this information? So this part is doing the job of what to forget. This which content you need to forget. And then it is important what to insert. Okay, and then you need to find out, combine this with transform xt, because you are getting some input at time t, which is given by xt, and then so see that how you are going to do the job of forgetting. So you have the net input xt at time t. This is your previous state at t minus 1. This will, both this input is taken, and it is processed through, means so this module has weights WF. What is the weight? WF. WF stands for forgetting. So weights corresponding to forgetting content. Okay. So WF into this vector dot product plus BF is your bias. So this is the net input reaching to this neuron. What is the output? I am saying the output will be controlled by sigmoid function, where sigmoid will be giving output between range 0 to 1. Okay. So FT will be computed like this. Is it fine? Okay. So you have to learn separate weights for what contents to be for. Then then we are going to talk about. So now you're talking about, for the same input xt and st minus 1, you are going to compute, okay, what content is important. And for that, I'll be learning separate weights. And that will be given by what? WC and PC. Okay. Input is same. But the job of weights is to find out which content is important, which weights to insert into the next stage. Okay. And then what you are going to do, you are going to compute new content. So the new content depends upon old content. This old content is controlled by forgetting part. Means out of the content which was available at t minus 1, which part I need to forget? That will be taken care by ft. So ft into ct minus 1. And then you are computing this ct dash based on the input, what content is relevant, what parts to be inserted, that you are going to compute with the help of it. Okay. And you are going to compute new content at time t. Is it fine? Okay. Now, once you have this, then you are interested what to be outputted at that time t. Because at every time you are going to get show some output. So what should be the output? So again, for that you need to learn a separate weights. That is O B O. Okay. Input is same. Okay. And you are going to compute what should be output. And you know what is the content at time t. So this is CT. So using this, you'll be able to show how to scale this output. How to scale my output. So what are the steps involved? I think I'll explain. So first part is based on the input st minus 1 xt. You are going to learn weights wf and bf so that you remember what to forget. Then what content should be inserted, what content should be brought in. Based on that, you will be able to compute what should be the new content at time t. So now you know what should be the new content at the conveyor belt at time t, and using that you will be able to find out what should be the new state at time. Okay. So this can be written in terms of algorithm. Okay. Once you know what you are doing, so what you say that you are given a set of samples. So, and let's say you are going to compute at for time capital T. So at t is equal to 1, you are going to compute what is the forgetting component F1. Then you are computing I1. Then you are computing C1, and then you are computing C1 tilde. Then you are this is the content at time t is equal to 1. Then you will be knowing what is the output at t is equal to 1, and then what is the state at t is equal to 1. Now knowing this can you compute at t is equal to 2? So you can unfold, keep on unfolding, and then after that you'll be able to know what is the loss. So there are what are the different kind of problems you're solving? One is your multiple input, single output. So you're computing H1, H2, H3, H3. Based on this, can you compute what is the average value of H3? Based on this, can you compute what is the net loss? And then knowing your loss, can you compute what is the how you change the weights? What is another kind of problem? You have single image, multiple output. How you will do this? You are going to compute H1, H2, H3, H3. At each stage, you are going to compute your loss function. And then what is the objective? That you want to minimize each one of this. Again, you have to learn what is that common weights W. But in this case, you have three kinds of weights. Forgetting weight, your input weight, output weights, bias. So you are going to learn. What is another kind of architecture? Multiple inputs, multiple outputs. Loss will be computed. Okay. So this is the architecture which you can visualize. The only difference between RNN and LSTM is the following. In RNN, the cell structure is very simple. It is not thinking about what to forget, what to insert, what are more important, what are not important. It's not. But what is the problem with RNN? It suffers from the problem of vanishing rate or exploding problem. But this you are able to resolve because the way you have conceived this problem, can you think this CT is a function of this? So if you differentiate CT with respect to CT minus 1, you'll find that this FT is going to be some constant number, and which is not small. Okay, so this is not going to create vanishing rate problem. Okay, so you can solve this one-to-many problem. You can solve many-to-one problem. You can solve many-to-many problem, and you can solve your many-to-many or name entity recognition. Okay, so I think I'll give some time for question answers. Okay, so what we have done, okay, we have talked about how your RNN and LSTM is different from NN. Then we have seen that what are the different kind of problems we can solve using this RNN and LSTM. We have also learned what is the problem of RNN and how LSTM is able to resolve this. So now, but the question is, what are the hot research in this area? Okay, so all these slides are not my slides. I have taken from different sources, references I will be telling you. Okay, but what I have done by going through various kind of materials, I am able to prepare something which can be of some importance to. Okay, so there is no research contribution in this slide. Okay, but yes, we have done some research, but this activity is not for research. This activity is for your basics. Okay, but if you're interested, I can tell you one of the important. I can tell you two important areas where you can do some kind of research. One is your how to solve this optimization, because ultimately you have to learn weights. Okay. So when you talk about the gradient descent method, one of the disadvantages of gradient descent method is that you may stuck into local minima. So how to come out from this local minima? So people have suggested many times. They talked about stochastic gradient descent. People are talking about many variants of stochastic gradient descent method. Okay, so using first order statistics, second order statistics, they are suggesting some algorithm. But can you also think about some method which can definitely perform better than one which are existing? Another is your area which many people have already explored and trying to explore, but this is still an open research area. That is your attention. Okay, because there are certain content in the text which are salient content, means the very relevant content. So how you should be able to come out and find out those salient content present in the text, salient content present in the game, salient content present in the videos. Okay, with less computational resources. Although there are certain architecture transformer based. Okay, so transformer based techniques have been suggested, which have come out to be very good, which looks into both, you can say, low level features and global level features. It means low level features, global level features in what? It can look into local contents and it looks also into global contents. But at present, the computational resources which is required for running transformer, this cannot be run in such simple. So with this, I stop my presentation, and if you have any queries.
Any query, then ask the question. Online participants also. No questions.
No questions, it means that you have not understood anything or you have understood everything. Okay. So both are not possible.
Sorry, we use LSTM for two major purposes. So the one is the loss in the gradient, right? And the other one is what to forget and what to remember. So the forgetting and remembering thing comes when we have a very large.
But the length of the input is very
large. So is there any specific your experiment can do to identify what kind of length? Because so in LSTM the complexity increases so much as compared to the simple RNN.
Sure.
So how to differentiate like when to take this?
So I think there is no such thumb rule because it depends upon problem to problem. Because sometimes when you talk about speed recognition, so you can have one audio clip which is of 100 seconds. But you can also have an audio clip of only 1 second. Because you are not fixing the size,
The moment if you fix the size, you say that okay, my audio content will be of only 1 second, then definitely you can think about it, okay, I'll use your simple RF. But if it is a variable length and this contains longer duration videos, longer duration your text, longer durations your paragraph, then your LSTM comes. But most of the cases, what are the problems you're solving? You are passing on one chapter and you are asking the machine to summarize the chapter. So do you think it is your 4 line or 5 line or 10 line chapter? So similarly, video. You want to summarize video. What is happening in the video? So again, the content of the video is you don't have video of only 5 frames. In general, you have video of what 100 to more than 100 frames. Yes? So that's why for most of the problem, you find that LSTM is the. You can think about what is the choice between LSTM and transform. But if I take my opinion, choice between RNN and LSTM, which is you see, it's not very complicated. There we were learning only W and B, but here we are using what? WF and then W0 and then we are using what? WI and these are the kinds of different ways we are learning. And this cell structure is same. So it looks a little complicated.
So in one of the slides, you mentioned that before this LSTM part in Agarwal part, you said that because we manage the gradient and to prevent all that, then you came to saying that we will take an average of all the HI that we get from the areas from that side, that part. Yeah.
No, when I was talking about that part, the relevance was different. You can see context was different. When I was talking about this, I said when your problem is to solve many to one problem, you have many words and the output is only one. So in that case, at various time units, initially there is no output you are observing. But your states, your S1, S2, S3, you are computing because they are being utilized by the successive successive set. So, but your computation can go wrong at various stages. Means that S1 can also go wrong, S2 can also go wrong, S3 can also go wrong. Okay, and then because of this, any one of this wrong computation of HIs, your loss can be different, your output can be different. So to resolve this, what you are doing? You are computing what is the average of this HIs, or what is the sum of this HIs, so that based on this one single value, you will be able to compute what is the net loss. So here the objective was different. But when I was talking about chaining rule, where I use chaining rule, you
That
have
was in updating the weight changing.
yes.
So here, like now you said that okay, if any one of those computations would go wrong, like H1, H2, or if it's n computations for all the H1, H, then won't taking the sum and then
Because
averaging it
you
will
are not,
actually
because at every time step you are not giving the output.
yeah, we are in computing the middle.
Your output
thing,
is observed at the last time.
Yeah.
So the HIs which are computed at the previous time units, they can also be computed wrongly. Do you agree?
Yeah.
So you have to see that those are not getting wrong.
Yeah, but
Or anyone.
some
So for this, yes. So this is the law of average behavior.
okay. But sir, if
You
any one
see,
child
let's
is
say
wrong,
if you have, you see how this average behavior statistics gives you good result. In this India, okay, you have election, but if truly exit report is computed, exit poll, I think it can go very correct. It can give very correct information. But the way samples should be taken, that should be done.
uniformly.
You have, let's say, an IT Delhi. I want to compute average age of the students of this institute. And you, let's say you have 5,000 students. Finding out, first know their age and then find out what is the average age of the institute can take long time. But if I take five samples from all the classes, even if I compute the average of this, that will found out to be nearly same as the actual average of the book. But if I'm doing sampling, okay,
But sir,
so here also the law of average will be there because it's not in one run. You are passing on many samples. Okay. So because of this law of average, you will find that ultimately what will be computed, it will be the actual.
so won't the successive cell will compute wrong if the previous cell has computed wrongly because we are passing H2 to H3.
No, I'm computing these. I am computing this.
Yeah.
But I am then we are computing one single value that is h. Okay. And then based on this h, I am going to compute the loss. Loss, how you compute loss function?
No, sir, that is okay, but if H2 went wrong, so we are not ending there, right? We are calculating till
It
Hn.
is not only by doing it with the help of only one sample, and it may go wrong. But if you are using thousands of samples for computing this,
Okay, and then we are averaging.
so then it comes out to be. Friends, let me tell you, if you start with some artificial neural network, you assign the weights, and you assign the weights, and you assign the weights. This initialization of weights can be different. But when you ultimately compute what is the accuracy of the model on the test data, or the same for your data, you may give 92.3. For your, it can be 90.7. For other, it can be 89.9. So there is not much variation. But there is the power of the algorithm is this that even if you start anywhere from any weights, okay, few of you may be taking 20 iterations, other may be taking 40 iterations, the third one may be taking 100 iterations, but ultimately you will be converging to that phase. And mathematically, I can show you that it is going to converge. What is your roots of x square? If you solve x square minus 4 is equal to 0, what are the roots? Plus minus, but now you solve numerically. Okay. You may get value 2.00001. 1.999999999. Is it wrong result? It's closer to. So when you are solving, I tell you one method, you get 2.0001, you are getting 1.9999. The other person may be getting yours 1.999989. It is very close to 2. So we consider this to be right.
Okay, any other question? Online participants, any questions from your side? Online participants, any questions? I think there is no question.
No question, huh? So thank you.
So thank you, sir, for your nice presentation.
But the learning will be more if we start implementing. Huh? Because if you won't implement, there will be no learning. Take small problem and you solve, okay, you learn more.
So now I request to Dr. Kamlesh Tiwari to present the book lecture to Agarwal sir.
Listen. Oh.
चलो हम लोग पीक में चलते हैं then we will be nice. I think we can take one photo of this. Please assemble and
मैंने बताया था क्योंकि मैंने
So there is some change in schedule. This lecture will go up to 1 p.m. and we will have lunch at 1 p.m. and the lab session will start at 1:45 to 3:30. 3:30 we will have tea, and at 4 to 6 there is the lecture of Adit. Okay. So be present, all of you, in the Adit's lecture. And same information for online participants also. So now we will have lecture up to 1 to 1:45 lunch, and 1:45 to 3:30 hands-on session, 3:30 tea, and at 4 to 6 we will have the lecture of Adit.
All right, welcome once again. This is Kulesh. So I will be starting the next session that is actually on the very similar lines. Professor Agarwal has talked to you on the sequence modeling, and essentially after sequence modeling, my topic actually revolves around the same thing. So you can just see that how what is the difference and what is the thing. Similar kind of topics is again going to be talked in this session also. Okay? Try to interact, try to understand what it is. So can you please open the slide, please? Where is the slide? KTRE.in on the same slide. Open KTRE.in. My website is KTRE.in/TALK talk/PPT03. Should I write it here? Here is the folder. KTRE.in. KTIWRI.in. Yeah, the same thing. Put it 3. 01, put it 03. 03. 03. I think there is something else. Something coming in before that, na? STQB, just take that part. Okay. So remove this last part. I sorry. PPT02, not 3. Yeah. I have given only one talk. Sequence modeling with RNA. Okay. Everybody full screen, please. Just get full screen. All right. Yes, level. All right. Okay. Very good morning, everybody. How are you feeling? Energetic? You got the tea? You are sweet?
Not looking energetic, feeling energetic, but you should look also.
All right. So in this session again we are going to talk about the similar line of thought. So the problem, I think this talk is going to be very light. Take it very light. So it is just a kind of discussion between me and you. And I wanted to pose you a small problem. So let's assume that I have developed a computer system, and from which I can ask that should I, there is a question whether I should go to see a movie or not. Let's assume that there is new movie release, and to this system I can ask this question: should I go to see this movie or not? It can give me an answer. Okay. So how should I make this? What should I put into the system? I put that whether what is the title of the movie, who are the actors, and what, where it is.
Sorry to interrupt, but you haven't shared the screen.
I did not share the screen. Okay. Thank you. Please asking. So I'm very happy to hear you. Can you tell me your name, please? Can you please tell me your name?
Yes, sir, it's Karthik.
Everybody, please clap for Karthik, because it is very important thing that he has done. So this is actually required. So every time, whenever I am speaking, you please keep stopping me, okay? Because otherwise, look, I am a little easy speaker, okay? Next speaker is very dangerous. So if you Aditya Nigam, he would be talking to you at 4. So at that time, I think you must stop him, otherwise he would take you till 9. Okay, as I'm telling that it is going to be 6, but session can go till 9, and you would also not leave. Okay, the style of teaching, is such that not leave. So this is very important. So you can think that it is a way of practicing that how you will stop Aditya. Okay, so once he told me कि अगर क्लास में आ गए तो पढ़ाए बिना तो भेजूंगा नहीं. Not possible that you are in his class and you don't understand the topic. Okay, so please do like that. On lighter note, okay, every time it becomes bad. So now can you see my screen? Hello, can you see my screen?
Yes,
Online
sir, it's
participants?
visible.
Great. All right. So I have, let's assume that I want to develop a system that is such that if I ask, I can ask from that system that should I go to see the movie or not. So what it should consider? It should consider that what is the movie, who is the director, and who are the star cast. If it is a Amitabh Bachchan movie, definitely I am going to see that. Something like that. So my preferences. That's why who movie I like, what kind of people my friends are, and what movie they have seen, they have rated. Multiple things you can tell that. Using that, let's assume that I have developed the system. There is a new movie release. I ask, should I go to see the movie? He says, yes. Okay, I can go there. Next day, I can ask from the system, should I go see the movie? What the system would say? Let's assume the answer was yes. What the system would say? Right? It would say yes, because system can say yes or no. It would say yes. I would again go and see the movie. Third day, I would ask what it would say. Yes. Fourth day, and how many times I have to see the movie? Have you seen this? Let's say when I was a kid, and you will also maybe have experience that if you go to your mom and tell mom, I want ice cream, what she says? What she says? No. What she says? No. So in the morning you ask mom, I want ice cream, he says no. Then you ask him at the time of lunch, then I need ice cream, he shows no. Then evening you say, he says no. In the night you say, yes. Can you see this? In our real life, what happens that we see that what we have done earlier, but our actual models are machine level ML models are such that that they don't see that what I have done earlier. ये नहीं जा रहा है ठीक से. Okay, so this has a problem. He does not consider that what he has done earlier. This is a very basic problem with all the kind of systems. Okay, every time the system would give me the same answer. How many times I can see the movie? Basic ML model has a problem that they don't see that what they have done earlier. So how can I bring this component to the machine level ML models so that they also remember that what has been done earlier? This is called the sequence modeling. In our life, lot of sequential data actually we encounter, and actually we want to do 4 different kind of problems. We want to solve 4 different kind of problems with them. One problem is about the sequence predictions. Sequence prediction means if I know that these values, what is the value going to be next? For example, in the stock market, I know that what were the earlier values. I want to predict that what is value going to be next. Weather forecasting, if I know that these days it is raining, so I think that next day is also going to be raining. Product recommendation, very interesting topic. Okay? So we do very different kind of things over here to find out that what product I should recommend to a person, because it can be dependent upon not only on your preferences but other preferences as well. Okay? Let's assume that there is a viral song coming, everybody is listening to that song, appreciating, but you have not heard about that. So he sees that other people are seeing, then he tells you. And it will also be possible that if you have recently purchased a cricket bat, it can suggest you that you purchase this ball also. Okay, so based on your history, based on how other people are doing, it can be suggested to you. The product recommendation is a very interesting idea. And then sequence classification. There are different kind of sequences. I want to classify them. For example, DNA sequence, you can tell that whether there is some problem that particular person has or not, what kind of life he is going to have. Anomaly detection, somebody comes somewhere, behaves in some way. So based on his actions, I want to tell that whether his actions are good or bad. Okay, you just see that whether the person is right or wrong. Sentiment analysis, the professor has talked much about that. That I want to tell that whether it is a positive sentiment or negative sentiment. Text generation. Now I want to generate the text. So I also talked about that. And one word I am telling that what is the next word? Music generation, image captioning, and then sequence to sequence translation. So text summarization comes into that, and language translation comes into that. Something written in one language, I want to write in another language. It is a kind of comprehensive list where actually we want to do different kind of things with the sequences. Sir has rightly pointed out that one of the major challenges is this, that I don't know that what is the size. Okay. Input, generally the model takes this fixed size input, but this kind of model does not have the fixed size of input, so we have an issue. And also there is one more thing I think I should bring in your attention, that there are something called long-term dependencies. Okay. And you can take the idea from this particular sentence. Here is a sentence: Agra is a great place. If you go there, you must visit dash. What it is? Taj Mahal? Everybody? Sure? It should be Taj Mahal. But but Taj Mahal and Agra, how distance they are? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 words. Okay, there is 11 word dependency. And you feel this dependency because if I change this Agra to Delhi, it becomes what? Huh? Yeah, NIT Delhi. If I put it France, you can tell what it should be. So there is a long-term dependency. So we must understand this. And this is again, there are 2 different kind of problems that our models have the problem that they actually generally machine learning models take the fixed size thing, and therefore we have to solve this particular problem. So how can I solve this problem? Let's assume that my size is not fixed length. So what should I do? So one approach would be you take the fixed length. Okay, forget about whatever come late earlier. Just take the 10 sentences, whatever is like that. But again, as we have just discussed, that if we do that, if you consider only fixed length, the first one, we are unable to model the long-term dependencies. Okay. Another idea is very good, and this idea is called bag of word. Bag of word you know, it's a kind of representation that whether this word is there in the inside the sentence or not. Look, everything is not important to us. Even if we speak the sentence in the is, am, or the, that, comma, semicolon, etc., they're not important. There are many such words. What are important words? So if I note down these important words, okay, these are the only important words for doing, for understanding my thing. Okay, I can say that dictionary also. Everybody has a dictionary. Okay, I have a different dictionary, you have a different dictionary, and let's assume that safely we can assume that this is a fixed size. So if I only speak 10,000 word, so I can create a 10,000 size vector, put everywhere 0. If I say any sentence, find out what words has been said. So for that word you put 1. Now whatever I can speak, whatever length I can speak, I'm not going to beyond this. So just use that thing, put into this particular vector, convert this to a particular vector, and then you can use that. This is a very good solution. Okay, this solution is called backup word. Again, it's a very good solution, but it has very serious problems because you are actually destroying what? You are destroying the sequence. Whatever way they can come. And sequence are the most important thing, and you have destroyed that. Just see these two sentences. David is good at math, but is bad in science. So he is good in math, bad in science, but if I change it, David is bad in math and good in science, I have just changed 2 words. Whether their representation is different? Different? No, representation, backup word representation is same because same word are used, but totally different sentences. Okay, so it is becoming a challenge. So you see the problem. We have to deal with the variable size of input. We have to maintain the sequence order, keep track of the long-term dependencies, and share the parameter across the sequences. Okay, so for that, sir has talked about that we have actually very interesting architecture. That's called the RNN. Because we're going to teach them this part today. So RNN, you are going to see this in your lab. Okay, so I request everybody to clap for the Rituraj. I like clapping. He is a wonderful and very humble student, and he happens to be a proud guide of Rituraj, but he is actually very equally good as me. So he is very good student, and I think you would be getting a lot of insights into the actual how to implement the model with that. Okay, I could not introduce him because I was not there on the first day. This I got a chance just to introduce him to make the things lighter. All right. Okay. Okay, this is what the model is generally. Okay, this is the model. This model this is a feed forward network. At the time t, I provide some input to this, and after some time, because एक unit तो लगेगा ना processing करने में, अगले minute में I can see the output. At time t plus 1, I can see what is the output. ये समझ में आ रहा है? So simple है. I am going to give some x I am going to provide, y I am going to get, y is output that I am going to get, but y I would get at the time t plus 1, not the same time. Same time I cannot get because ऐसा क्या जैसे दिया वैसे कैसे मिलेगा कि टाइम तो देना पड़ेगा ना प्रोसेसिंग का. लेट्स assume 1 unit of time processing I am given. This model can only take what? 1 unit. Can I modify this so that all these things can be handled with all these requirements can be handled by this model? And this is what it is. I am going to add one more neuron that is actually hidden neuron to the hidden layer. Add कर दिया. I am going to connect this with everything else, everything here. Okay, I am going to connect this. And at the time taking output, at the time when I take the output, तो अभी क्या इसको तो कोई काम नहीं है. Next time जब मैं अगला input दूंगा, at that time this thing would also be going inside here. This is the small change I am going to do. ये small change समझना आसान मतलब जरूरी है यहाँ पे कि what I have did, I have created one more neuron here, but ये independent कुछ नहीं हो रहा है, ये बाहर रखो, ठीक है, ये बाहर रखो. इससे आउटपुट पे कोई फर्क नहीं पड़ता. लेकिन अगली बार जब हम दूसरा इनपुट देंगे, एट दैट टाइम आई एम गोइंग टू टेक दिस वैल्यू और पुटिंग इट इनसाइड, ठीक है। तो उस समय चूंकि यहाँ पे अभी इनपुट में आ गया, इनपुट में ये था लेकिन ये भी इनपुट में है, ये सारे के सारे इससे कनेक्टेड हैं, तो ये जो आउटपुट है उस पर भी डिपेंडेंट हो जाएगा। यू सी दिस, in the next time this output is going to be also dependent upon this neuron also. इससे होगा क्या, इससे होगा ये कि let's assume that you wanted to find out what is the output at the time t plus 1. So एक मिनट पहले जो इनपुट दिया था xt पे, वो आपको चाहिए तभी तो आप बता पाओगे, but to get this output, this input is also required. How can you get this input? So t minus 1 में जो इनपुट दिया था उससे ये कंप्यूट हुआ था, उससे ये कंप्यूट हुआ था. So you can connect this thing to here. What does it mean? That this output depends upon this input and this input also, because you can see that connection is there. So it is also dependent on this. Yes or no? But again, this you cannot compute until this value is also available. Okay, this value was available when the previous value was provided. At that time, whatever you have computed. So you can unfold it in the time. This is called the unfolding of RNA in time, and so on. By this, you can see that output is dependent upon all the things that you have given to the network. And my model is fixed size. Very interesting idea. Okay, very interesting idea. So this is how the RNA is usually made. RNAs can be used in 4 different kind of settings. The first setting is this, where you provide something to it and it is going to give you the output. Okay, you give something and it is going to give you some output. So one input, one output. For example, if I want to generate a story, so I say there, I provide there, then system is telling was. I put was inside. It says A, I put A, king, his name was. It's a control issue. So somebody's name comes, what he did, everything. So every time you are going to enter one thing, you are going to get output as a one thing. This structure says that there is only one RNA is required. You keep feeding, getting output. This is the second setting where you provide one time you provide the data, and immediately you get some output. In next point, ये जो है ना next time है, okay, ये 3 नहीं लगाएंगे. अगली मिनट में वही कुछ और भी देगा, तब तक देता रहेगा जब तक इंड ऑफ फाइल नहीं हो जाता. इसका एग्जांपल है, I provide an image to this system and it is going to give me description. So कैसे description है, बटन दबाते रहो, एक के बाद एक वर्ड आता रहेगा, जब तक इंड ऑफ लाइन नहीं आ जाता तब तक मैं उसका आउटपुट लेता रहूंगा. एक आउटपुट until इंड ऑफ लाइन कम्स. ठीक है ना, एक इनपुट मल्टीपल आउटपुट. ये अलग अलग टाइम पे है, नॉट द सेम टाइम. अगेन दिस इज डिफरेंट थिंग, जहां पे बार-बार आप इनपुट देते जा रहे हो, आउटपुट नहीं है, आउटपुट लास्ट में आता है. क्या है, सेंटेंस. जो सेंटेंस का क्लासिफिकेशन है कि ये पॉजिटिव सेंटेंस है, नेगेटिव सेंटेंस है ना. ये सेंटेंसेस काफी कॉम्प्लेक्स होते हैं ना, है ना, काफी कॉम्प्लेक्स होते हैं. इट्स नॉट दैट इजी टू टेल. फॉर एग्जांपल कई बार लोग कहते हैं ना, जैसे मैंने पॉजिटिव सेंटेंस, पॉजिटिव वर्ड है, नेगेटिव वर्ड है. नॉट इज नेगेटिव वर्ड. किसी भी सेंटेंस में नॉट आ गया तो मैं कहूंगा कि वो नेगेटिव सेंटीमेंट है ना. लेकिन people say in a very different way that it is not good to tell that food is bad. अब क्या है, बैड भी आ गया, नॉट गुड भी आ गया, बट ये तो अच्छी बात कह रहा है. सेंटेंस आर वेरी डिफिकल्ट. ओके, स्पेशली हिंदी वेरी डिफिकल्ट. ओके, देयर इज समथिंग कॉल्ड वाला. ओके ना, चाय वाला मतलब कौन, हाँ बोलो. चाय वाला मतलब टी सेलर, नॉट प्राइम मिनिस्टर. ओके, घर वाला मतलब घर वाला मतलब लेडीज की पर्सपेक्टिव उसका हस्बैंड. ओके, दिल्ली वाली गाड़ी मतलब दिल्ली वाली गाड़ी में, चलो अच्छा भोपाल वाली गाड़ी, दिल्ली में तो नहीं समझ पाएंगे, भोपाल वाली गाड़ी में क्यों? जो गाड़ी जो भोपाल जाती है, अजीब की वाला से मतलब ही नहीं निकल पा रहा है, वाला का मतलब क्या निकालूं मैं? So sentences are very complex because sometimes we add something and the context completely changes and बहुत सारा different language that's very difficult to understand. Yeah, you are feeding one by one word and then at the end you are going to see that whether it is positive or negative. And again, this kind of architecture, for some time you are sending telling something and after some time the result start generating and actually then it takes some time to generate. Generally happens in language translation. ओके हिंदी में बोल रहा हूँ, इंग्लिश में ट्रांसलेट करना है, 2-3 मिनट लगेगा, 2-4 सेंटेंसेस में बोलूंगा, उसके बाद जनरेट करना शुरू करेगा और जब मैं रुक जाऊंगा उसके बाद जनरेट करना है ना। तो इस तरीके से देयर आर 4 वेरी जनरल सेटिंग्स जो इसके अंदर होती है। बहुत ही हायर लेवल से देखा जाए तो आप इसको एक क्लास की तरीके से देख सकते हैं कि ये एक आरएनए एक बॉक्स है जिसमें आप कुछ इनपुट देते हैं, अब इनपुट देते हैं ट्रांसफॉर्म होगा, तो मैंने सोचा कि इनपुट का ट्रांसफॉर्म यू है, यू मल्टीप्लाइड बाई एक्स। पिछले वाला स्टेट जो कि वो उसके अंदर जा रहा था वो कहा Sn-1 मल्टीप्लाइड बाई W, उसका कुछ वेट होगा, ये मल्टीप्लाइड हुआ, ये दोनों आपस में ऐड हो जाएंगे, इसके बाद इसके ऊपर कोई आप लगाओगे, उसके आप कोई tan h लगाओगे या कोई एक्टिवेशन फंक्शन लगाओगे। सो अगर मुझे अगले स्टेप में जाना है तो क्या करना पड़ेगा कि मेरा अपना स्टेट को W से मल्टीप्लाई करो और जो मेरा इनपुट है U से मल्टीप्लाई करो, उसको एक्टिवेशन लगाओ, अगला स्टेट मिल गया मेरा, मैं स्टेट अपडेट कर दूंगा। If you need the output depends only upon sync. So जो मेरा स्टेट है उसका जो ट्रांसफॉर्मेशन करना है आउटपुट ट्रांसफॉर्मेशन, और उसमें आप फिर एक सिग्माइड लगा दो या कोई एक्टिवेशन लगा दो, उस तरीके से आउटपुट ले लो। तो ये है इसका बेसिक मॉडल, ठीक है। आरएनए का बेसिक मॉडल, उसमें कितनी तरीके के पैरामीटर है? 3 तरीके के पैरामीटर। कौन से? यू, डब्ल्यू और वी। एक आउटपुट से रिलेटेड है, एक इनपुट से रिलेटेड है, दूसरा स्टेट ट्रांजिशन से रिलेटेड है। तो अभी थोड़ी देर पहले मैंने देखा कि मान लीजिए मैंने एक सिस्टम बनाया जिसको मैंने h दूंगा, e बताता है, e बताता हूँ तो l देता है, l देता हूँ तो l देता है, फिर l देता हूँ तो o देता है। अरे ये कैसे? l देने पे तो l देता था, l देने पे o कैसे दिया? क्योंकि दूसरा l है, पहला l और दूसरा l क्या है? आने होने के बाद स्टेट बदल गए थे, दैट्स व्हाई इट इज अ डिफरेंट l। सो आउटपुट ओवरऑल क्या हुआ? h e l l o, hello, understand? So I want to develop this thing। एक ही चीज है, ये टाइम के साथ है, समझने वाली बात। This is with respect to time, so there is only one thing, I want to find out what should be the right parameter of this u, w and v so that I can find out the right correct thing। So we have seen that, okay, what we have seen, that next stage is computed by this formula and the output is computed by this formula। So okay, system is giving, how can I train it? System is giving some output and I know that what should be the right output, I know that because at the time of training I know, at least at the time of training I know what should be the right output। So the difference between the output that are given here and actual output, I can compute with using those two values, I can compute the loss। How can I compute the loss? Difference of these two values of square, okay, L1 loss, difference of these values, L2 loss, or any other kind of loss you can apply right now। So what is loss here? What is loss at the time 2? What is loss at the time 3, time 4, time 5? So total loss is going to be loss every time there will be loss, that is JT, and over the period of time you just find out the summation of that loss। And now your objective will be to train and find out what are the parameters and what are the parameters that can reduce this particular value। This is what the training is। I do something so that this J value is reduced। I change the parameter in such a way that the J value is actually reduced। Okay. Okay. So let's assume that I wanted to find out the parameter with respect to W, U and V तीन थे ना मेरे पास। Let's assume I want to find out a specific W। सीधी सी बात है भाई, W का डेरिवेटिव निकालो उस वाले W के रिस्पेक्ट में, और W की अभी जो करंट वैल्यू है उसमें से अल्फा टाइम करके घटा दो, कितने लोग समझ आ रहा है? कोई भी एक्सप्रेशन है उसको आप पार्शियल डिराइव करो उस वाले पैरामीटर के रिस्पेक्ट, पार्शियल डेरिवेटिव की वैल्यू निकालो उस w की वैल्यू। ये बताता है कि अगर आप इतना बढ़ जाओगे तो मैं भी बढ़ जाऊंगा। आप घटाना चाहते हो तो आप जा रहे हो नेगेटिव डायरेक्शन, माइनस आप अल्फा w, क्योंकि आप इरेडो घटाना चाहते हो। अगर आप बढ़ाना चाहते होते तो प्लस करते हैं। डेरिवेटिव मतलब स्लोप। स्लोप आपको पता है, स्लोप के डायरेक्शन में जाएंगे तो ऊपर जाएंगे, स्लोप के नेगेटिव में जाएंगे तो आप नीचे जाएंगे। तो सीधी सी बात है। अब इसका डेरिवेटिव निकाला कैसे जाए, आई विल नॉट गो इनटू दैट मैथमेटिक्स। ये पूरा थोड़ी देर पहले मैंने कहा समेशन आप देखते था। समेशन जो है ये मल्टीप्लिकेशन टर्म में आ जाता है, क्योंकि ये इसके अंदर हम चेन रूल लगा सकते हैं, फिर इसके बाद कंप्यूट कर सकते हैं और एक बहुत बड़ा सा टर्म आएगा। आई नॉट गो इनटू दैट मैथमेटिकल डिटेल, रिक्वायर्ड नहीं है। लेकिन हम इसको ऐसे देख सकते हैं कि एक बहुत बड़ा सा मल्टीप्लिकेशन टर्म आता है, और अभी उसकी भी जरूरत नहीं है क्योंकि अकेले इसका प्रूफ ही एक सेशन से ज्यादा लेता है। लेकिन आप ऐसा मान लीजिए कि जो बहुत सारे टर्म का मल्टीप्लिकेशन आया था, मल्टीप्लिकेशन ऑफ मेनी टर्म्स, एवरी टर्म इज बाउंडेड बाय सम नंबर। एक कांस्टेंट से वो छोटा रहेगा, इसका प्रूफ किया जा सकता है। अगर वो कांस्टेंट एक से कम है, कांस्टेंट है तो एक से बड़ा हो सकता है, छोटा हो सकता है। एक होने का कोई मतलब नहीं है, एक होने से छोटा क्या एक नहीं हो सकता? वो we actually talk in terms of ना numbers 1 2 3 4 5 6, इसलिए हमको लगता है 1 2 3 4 नंबर होते हैं। एक्चुअली 1 2 3 4 नंबर नहीं होते हैं, रेंज ऑफ नंबर होता है। उसके बीच में एक भी एक नंबर है। मैं कहूँ 1 से 2 के बीच में कितने इंटीजर है, मान लो 0 और 1 के बीच में कितने हैं? 1 से 2 के बीच में देखो 1 आता है, इसलिए 1 से 2 ले रहा हूँ। 0 से 2 के बीच में मैं देख रहा हूँ, 0 से 2 के बीच में 1 आया, लेकिन 0 से 2 के बीच में नंबर कितने हैं? इनफाइनाइट नंबर है। तो उसमें ये प्रोबेबिलिटी कि आपको 1 मिले, क्या है इसकी प्रोबेबिलिटी? 0, बहुत कम, नहीं 0। कोई भी रेंज ले लो, कोई भी रेंज ले लो, उसमें इनफाइनाइट नंबर होते हैं। ये सब प्रूफ है, डायरेक्ट आप जानते होंगे। कोई भी आप इफ यू पिक एनी रेंज, देयर आर इनफाइनाइट नंबर्स इनसाइड दैट। ओके, सो बड़ी मुसीबत हो गई। इनफाइनाइट नंबर है और एक पक्का नंबर निकालना बहुत मुश्किल हो गया। यही चीज प्रॉब्लम पहले भी आई थी, कल वाली क्लास में जब हम देख रहे थे ना, जब हमने कहा था कि हम बहुत सारे लेयर लगा देंगे तो लास्ट वाले लेयर को 1 चाहिए था। अब वो पॉसिबिलिटी तो फ्रैक्शनल है वेट, उसमें 1 को मिलने की प्रोबेबिलिटी 0 है। और आश्चर्यजनक बात ये है कि अगर आप इसके बीच में कोई नंबर सर्कल करें, एक नंबर आपको मिलेगा, उस नंबर की प्रोबेबिलिटी क्या थी? 0। तो एक ऐसी इवेंट जिसकी प्रोबेबिलिटी 0 है वो भी हो जाती है। आप सवाल पूछो, कोई इवेंट है ऐसी जिसकी प्रोबेबिलिटी 0 होगी? आपको भी नहीं, लेकिन मैं बता रहा हूँ ना, 0 और 1 के बीच में एक नंबर निकालो, कोई भी नंबर निकलेगा, उस नंबर के आने की प्रोबेबिलिटी कितनी थी? और वो आ गया। 0 वाली भी प्रोबेबिलिटी वाली चीजें हो जाती है। आप देखो ये चीज, तो बाय द वे मैं करेक्ट कर रहा हूँ, ठीक है? सिर्फ मजाक के लिए बात नहीं कर रहा हूँ, मैं बहुत सारी बातें मजाक के लिए करता हूँ, लेकिन ये नहीं है। 0.9 देखो, अगर ये वैल्यू 1 से छोटी है, मान लो 0.9 है, और 0.9 का अगला 0.8 1 7 5 6 5 5 9 5 3 4 8 3 8, देखो 4-5 बार टर्म में मल्टीप्लाई करते ही ये हो गया 0.39। तो ये वैनिशिंग ग्रेडियंट है, ऐसे एक्सप्लोडिंग ग्रेडियंट है कि अगर आप थोड़ा सा उसको 0.9 बढ़ा दो ना, तो ये 1 होगा, 1.5, फिर 1.29, 0.3, 0.25 खड़ाक से बहुत बड़ा हो जाएगा। तो ये बड़ी प्रॉब्लम हो जाती है कि ऐसा इसको ट्रेन करने में जो सबसे बड़ी प्रॉब्लम है, जो हमारे आरएनएस को ट्रेन करने की सबसे बड़ी प्रॉब्लम है, the biggest problem is because of this chain rule, this circuit becomes very large and therefore vanishing and splitting gradient problem comes, and therefore we cannot predict. बड़ी प्रॉब्लम, बहुत बड़ी प्रॉब्लम। उसका सॉल्यूशन क्या है? उसका सॉल्यूशन बहुत कुछ नहीं है। वन सॉल्यूशन इज दिस, दैट इफ द सी, इफ आप देखते रहो कि अगर ये जो मल्टीप्लाइड टर्म है अगर वो एक निश्चित वैल्यू से बड़ा हो जाए या निश्चित वैल्यू से छोटा हो जाए, तो वो आप फिर वही छोटी वैल्यू लो, उससे छोटी जाके मत लो। दूसरा तरीका होगा ट्रंकेटेड बैक प्रोपगेशन, जिसमें आप कहो कि लास्ट की कुछ वैल्यूज ही मैं कंसीडर करूंगा ताकि आप आगे बढ़ सको। और अगला तरीका है LSTM, जिसके बारे में हम आगे बात करेंगे। कोई सवाल? अभी तक सबको समझ में आ रहा है? कुछ नई चीज पता चली? नहीं, सर ने सारी चीज बताई थी, ठीक है। अगला चीज देखता हूँ मैं। सर ने ये भी बता दिया था LSTM, है ना। LSTM उसकी प्रॉब्लम को सॉल्व करता है, ठीक है। ये जो ग्रेडियंट वाली प्रॉब्लम है इसको सॉल्व करता है। कैसे करता है? LSTM इज नॉट, सबसे पहली चीज है कि LSTM इज नॉट ए सिंगल थिंग, इट कंटेन्स 4 स्पेशलाइज्ड न्यूरल नेटवर्क सर्किट। कितने? 4 अलग अलग सर्किट बना के रखता है। 4 अलग अलग न्यूरल नेटवर्क सर्किट्स हैं और वो अपने आप लर्न करते हैं कि व्हाट इज द राइट पैरामीटर अलग अलग काम को करने के लिए। जैसे सर बता रहे थे वही कहानी है कि मेरे पास कोई पहले मेरे पास कोई हिडन स्टेट है, वो हिडन स्टेट अपडेट होता है, ठीक। उसी हिडन स्टेट से मेरा आउटपुट आता है। ये मेरा हिडन स्टेट है, इसी हिडन स्टेट से आउटपुट आएगा। अगर मैं आउटपुट चाहूंगा तो हिडन स्टेट को ले लूंगा, उससे मैं अपना आउटपुट निकाल लूंगा। हिडन स्टेट जो पहले था उसको मैंने अभी यहाँ कोई इनपुट दिया, मतलब एक के बाद एक जो वर्ड्स आ रहे हैं ना इनपुट वाले, वो यहाँ से ऐसे जाएंगे, पिछले हिडन स्टेट के साथ कंबाइन होंगे और इसके बाद कुछ कंप्यूटेशन होगा और अगला स्टेट मेरा चेंज हो जाएगा और मैं ऐसे स्टेट चेंज कर दूंगा। हमारे पास जैसे सर ने कहा एक कन्वेयर बेल्ट है, आप ऐसे मान सकते हो कि एक और पैरामीटर भी है जो कन्वेयर है। उसमें क्या है कि एक वैल्यू स्टोर्ड है ना। वो वैल्यू ये बताती है कि राइट नाउ मुझे क्या करना है। बड़ी इंपॉर्टेंट बात बता रहा हूँ, राइट नाउ मुझे क्या करना है। अब मुझे बताओ कि मान लो कि मेरे पास, देखो मैं लिख नहीं पा रहा हूँ यहाँ पे, तो मैं ऐसे ही बता रहा हूँ, मतलब लिखने में ज्यादा मजा आता है। अरे बहुत बढ़िया, थैंक यू। सो ये बताओ मुझे कि मेरे पास एक वैल्यू है 10, ओके। मैं कुछ करके इसको बनाना चाहता हूँ 15, ओके। आई वांट टू मेक इट 15, तो मैं कैसे करूँ? कैसे करूँ, कोई तरीका बताएगा? हाँ? इधर, अरे 10 में क्या इधर है? 15 से 10 में इधर कहाँ से आ गई? 15 से 10 करना है मुझे, ठीक है। 5 डिफरेंस है, हाँ बताओ। फिर 5 ऐड कर दूं? वेरी गुड। आपने कहा कि सर इसमें ऐड करो 5, ये 15 हो गया। कोई और तरीका? मल्टीप्लाई 1.5, ओके। मल्टीप्लाई करो 1.5 का मल्टीप्लाई करो और ये हो गया 15। और कोई तरीका? दोनों काम करना है मुझे। मैं मल्टीप्लाई कर दूं इसमें, पहले मैं मल्टीप्लाई कर दूं 0.5 का, तो ये बन जाएगा 5। इसके बाद मैं इसमें ऐड कर दूं 10, अब ये 15 हो जाएगा, है ना। है तो बहुत सारे तरीके इसको चेक करने के लिए, लेकिन इन तीनों तरीकों में जरा डिफरेंस देखो। पहला तरीका ये बताता है कि मैं जितना मेरे पास था उसमें मैंने कुछ और सीख लिया, आई हैव लर्न समथिंग, है ना। आई हैव लर्न समथिंग, दिस इज व्हाट द लर्निंग इज। 1.5 मतलब मैंने अपनी लर्निंग को इनहेंस कर दिया, है ना। जो हमारी लर्निंग थी बड़ी इंपॉर्टेंट थी, उसको मैंने आगे बढ़ा दिया, इनहेंस कर दिया। कभी कभी होता है ना, आगे जो वर्ड आता है उसके कारण मुझे लर्निंग इनहेंस करना होता है। नहीं समझ में आया तो ये देखो कि अगर कोई सेंटेंस चल रहा है, बाद में फुल स्टॉप आया, क्या मतलब हुआ? कुछ ना भूल जाओ, नया शुरू हो रहा है, जीरो से मल्टीप्लाई करना पड़ेगा। तो जनरली इसको इनहेंस की जगह फॉरगेट बोला जाता है, हाउ मच आई हैव टू फॉरगेट। और जनरली इसकी वैल्यू इसलिए क्योंकि फॉरगेट टर्म होता है तो जल्द कम होता है। तो दूसरा तरीका क्या है कि पहले मेरी जो वैल्यू है उसमें मैंने कुछ फॉरगेट किया, मैं भूल गया पहले कि मुझे ये नहीं चाहिए, मुझे कुछ लगता है कुछ कंपोनेंट डाउन करना चाहिए, तो 15 पहले मैंने कुछ फॉरगेट किया, आधा मैंने कम कर दिया, क्योंकि आगे जो बात कही गई उसके कारण मेरी प्रोबेबिलिटी उस वर्ड पे आधी हो गई। पहले जो मैं सोच रहा था कि ये वर्ड आने वाला है उसकी प्रोबेबिलिटी मेरी आधी हो गई। फिर कुछ और आया जिसके कारण मुझे नई चीज सीखने के लिए मिली, मैंने उसमें उसकी चीज को ऐड कर दिया, है ना। तो ये जो सेकंड वाला मामला है, ये आपकी दोनों ही चीजों को इनकॉर्पोरेट करता है। क्योंकि अगर आप ये वाला चीज चाहते हो कि आप जो है मल्टीप्लाई करो तो ये वाली चीज को जीरो कर देना, अगर आप ये वाला चीज चाहते हो तो यहाँ पे 1 कर देना, समझ रहे हो ना। तो ये जो दूसरा तरीका है ये एक ज्यादा जनरलाइज तरीका है, एक बात समझ गए। तो ये जो मेरी वैल्यू है कि अभी करंट मेरा क्या चल रहा है, अगर इसको मुझे अपडेट करनी है नई वैल्यू के ऊपर, तो मुझे ct को क्या करना चाहिए कि ct-1 में कुछ मुझे मल्टीप्लाई करना चाहिए और कुछ मुझे इसमें ऐड करना चाहिए, ये दो चीज करना चाहिए। दूसरी बड़ी चीज आ जाएगी, नई चीज आ जाएगी। फिर उस आधार पे मुझे अपना हिडन कैलकुलेट करना पड़ेगा ना, ये मेरा स्टेट है। अगर मुझे अपनी हिडन वाली चीज को कंप्यूट करना है तो मैं क्या करूं, मैं ऐसा करूं, हिडन वाली चीज को कंप्यूट करना है तो क्या करूं, एक चीज इसमें और आती है कि अगर कोई मुझे बता दे कि मेरी कितनी लर्निंग है, तो ये जो ऐड करने वाली बात है उसमें एक चीज और आती है ना, ऐड कैसे करें, दो तरीके से ऐड होता है, आगे बढ़ाना और पीछे ले जाना। एडिशन में नेगेटिव भी तो होता है, तो यहाँ पे मुझे एक साइन को भी इंट्रोड्यूस करना पड़ेगा कि जो मुझे लर्न करना है वो पॉजिटिव डायरेक्शन में करना है या नेगेटिव डायरेक्शन में करना है। ठीक, अगर मैं ये फार्मूला बना लूं तो मेरा काम पूरा बन जाएगा और मैं आगे की तरफ जाने लगूंगा। इस फार्मूले को समझ जाओ, मेरा काम खत्म हो गया। ये फार्मूला समझ में आ गया, मेरा काम खत्म हो गया। अब मैं इसका मॉडल दिखाता हूँ, आपको सब कुछ सीधा सीधा समझ में आ जाएगा कैसे होगा। ये बताओ मुझे कि साइन जो है कौन देता है, मुझे कौन सा फंक्शन मुझे साइन देता है, tan h की वैल्यू +1 से -1 होती है। कौन सी चीज वैल्यू देती है, वैल्यू यहाँ चाहता हूँ, अब ये तो नेगेटिव नहीं हो सकता ना, अगर साइन कोई और दे रहा है तो ये वैल्यू तो नेगेटिव नहीं हो सकती। इसके लिए मुझे लगाना पड़ेगा सिग्माइड, क्योंकि सिग्माइड देता है 0 और 1 के बीच में वैल्यू, है ना। और यहाँ मल्टीप्लाइंग फैक्टर है तो अगेन इसके लिए मुझे चाहिए क्या, सिग्माइड। ठीक है, समझ आ गया। चले इसको बंद कर दूं, ऐसे बच जाएगा सारा। ओके, सो मैं नेक्स्ट स्लाइड पे जा सकता हूँ। अब देखो मैंने क्या लिखा, थोड़ी देर पहले हमने फार्मूला लिखा था, उसको याद है ना, याद है ना, अरे बेटा दिया है। अच्छा, कुछ लोग तो यहाँ में बैठे हैं जिनके पास कागज तक नहीं है, ऐसा क्यों है भाई? मतलब ये देखो, इट्स नॉट द मूवी। बस ये तो मैं सीरियसली कह रहा हूँ, तो ऐसा है कि मजा नहीं आता है जब तक लिखोगे नहीं। मेन जो है ना न्यूरॉन, मैं आपका न्यूरॉन ट्रेन करने की कोशिश कर रहा हूँ, और उसकी जो इन पॉइंट है आपके हाथ में है, कुछ लिख लो, कुछ भी लिख लो तो याद रहेगा, जैसे कागज में लिखा था, कागज खुल जाएगा दिमाग में लिख जाएगा। चलो कोई बात नहीं, चलो फार्मूला याद है ना, क्या था, पिछला स्टेट में मल्टीप्लाई करेंगे कुछ प्लस हम tan h लगाएंगे और इसके बाद जो है उसकी वैल्यू को ऐड करेंगे, यही तो करेंगे। तो आओ चलो, एक हमारे पास नेटवर्क है जो बताता है कितना फॉरवर्ड करें, कितना फॉरगेट करें, जो ये वैल्यू है उसमें कितना फॉरगेट करें, उसके लिए एक नया नेटवर्क बना दो। मेरे को दिमाग नहीं लगाना, ये जो वैल्यू है दिस w, यहाँ पे मान लो कोई पैरामीटर है w फॉरगेट, और उसमें जो है ये दोनों वैल्यूज लो और उसमें दो, यही नेटवर्क बताएगा कितना फॉरगेट करें, ft की वैल्यू निकालेगा, ft को ct -1 से मल्टीप्लाई कर देगा, कितना फॉरगेट करने है। ये फार्मूला सभी समझ में आ रहा है, पिछले से याद नहीं करना, देखो अभी समझ लो। ये जो है बहुत सिंपल समझ में आना चाहिए, कितना फॉरगेट करना है। देखो वो जो फार्मूला था, उसमें फॉरगेट कितना करना है मैं निकाल रहा हूँ, जो वैल्यू थी पहले उसमें फॉरगेट करना था, ct-1 के साथ कितना फॉरगेट करना है ऐसे निकालूंगा, ये समझ में आ रहा है। इसमें कुछ नहीं समझना, पिछली जो वैल्यू, अभी वाली वैल्यू, पिछली वाला स्टेट, इन दोनों को इस नेटवर्क को दिया, तुम बताओ कितना। देखो एक वेट है, वेट से मल्टीप्लाई किया, तुम बताओ वेट से मल्टीप्लाई है, उसमें बायस जोड़ दिया, बायस भी ट्रेन होके ही आया पैरामीटर, ठीक है, बायस भी ट्रेन होके आया पैरामीटर है, तो हमको पता चल गया कितना फॉरगेट करना है। ठीक, ct into f एंड देन ct का एस्टीमेट है, यहाँ पे ct का एस्टीमेट क्या है, ये देखो tan h से पता किया इसका डायरेक्शन कितना होगा, tan h से पता किया इसका डायरेक्शन कितना होगा, और पता चला गया, हाँ tan h से पता किया इसका डायरेक्शन कितना होगा, और कितना मैं उसमें जोड़ू घटाऊं, ये भी कोई दूसरा नेटवर्क ही बता रहा है। एक दूसरा नेटवर्क ट्रेंड है जो बताता है कि हमें अभी जो दिया जा रहा है उसके कारण जोड़ना घटाना कितना है, उसका डायरेक्शन कितना है, इन दोनों को मल्टीप्लाई करते हैं और इसके अंदर जोड़ देते हैं, अगला वाला स्टेट आ जाता है। फॉर्मूला समझ में आ गया? कितना सिंपल फॉर्मूला है ना, बहुत ही सिंपल फॉर्मूला है, इससे ज्यादा इसमें कुछ नहीं है। आई एम वेरी फास्ट, आई थिंक यू आर वेरी फास्ट। ठीक है, बहुत जल्दी समझ रहे हो आप लोग। ये समझ आ गया? बोलो नहीं? ये फार्मूला सब लोग ध्यान से देखो। अभी थोड़ी देर पहले यही लिखा था ना कि जो पिछला वाला था उसमें टारगेट करना है यार बहुत बात है। हाँ, उसमें फॉरवर्ड, इसमें जो है कितना टारगेट करना है और कितना सीखना है, उसके साथ डायरेक्शन को लगाना है। डायरेक्शन निकालने के लिए इसके ऊपर तो दिमाग लगाना ही नहीं है आपको, क्योंकि ये न्यूरल नेटवर्क से निकल के आएगा। हमने कहा कि ये सारी वैल्यू सप्लाई करो, न्यूरल नेटवर्क बता देगा किस तरह डायरेक्शन में जाना है। ये सारी की सारी टिक पैरामीटर्स टाइनेस लगाया था, क्यों? क्योंकि डायरेक्शन बताएगा। पिगमेंट लगाया था उसकी वैल्यू बताने के लिए। यही वही फार्मूला है। ct इज इक्वल टू, इस तरीके से ct कैलकुलेट हो गया। st कैसे कैलकुलेट होगा? st इज द आउटपुट। तो आउटपुट कितना होगा, यहाँ पे एक फार्मूला लगा दिया जिसने यहाँ पे लेके tan s के साथ ct के साथ ot बता दिया तुम्हारे आउटपुट क्या होगा। इस तरीके से आउटपुट कैलकुलेट हो गया। तो ये नेटवर्क सही से काम करेगा, इसमें कोई प्रॉब्लम नहीं है, क्योंकि अभी हमारे पास स्पेशलाइज्ड न्यूरल नेटवर्क है जिसको सीख रहे थे। बहुत इंटरेस्टिंग पेपर है और 1997, ओके, सो रेफरेंस है लॉन्ग शॉर्ट टर्म मेमोरी 1997। तो बता रहा था ना कि ये सारी चीजें 1997 उस समय बन चुकी थी, कोई यूज नहीं कर रहा था। 2013-14 में स्टार्ट हुआ फिर से इसको लेकर बहुत सारे पेपर इसके ऊपर काम करना, 12-13 के बाद से स्टार्ट किया फिर से इसके ऊपर, और इसके बाद भी बहुत दिनों तक ऐसे रखा रहा। अब बताओ अगला नेटवर्क कैसे बनाऊं मैं, इसको अच्छा करना चाहता हूँ। एज ए रिसर्चर आप सोचोगे कि मैं इसको अच्छा करूँ, क्या करूँ? कोई सजेशन? रिलेटिव पोजीशन चेंज करके देखो कि क्या कम नंबर ऑफ पैरामीटर में काम चल जाता है, क्या जो इतने सारे थे उससे कम न्यूरल नेटवर्क से काम चल जाता है, वही काम मिल जाता है। ये अगला पेपर होगा, आप लोग बता रहे हो ये अगला पेपर होगा ना, कि हमारे पास एक वर्किंग मॉडल है, अब उसके साथ खेलो, उसमें चीजों को चेंज करो, अलग अलग तरीके से कनेक्शन लगाओ और देखने की कोशिश करो कि क्या कुछ करने से कम नंबर ऑफ न्यूरॉन से काम चल जाएगा। लेस कंप्यूटेशन करके ये काम कैसे कर सकते हो? फिर मैंने कहा सिर्फ 3 न्यूरल नेटवर्क में बनाऊंगा, उससे काम जो करा लूंगा सारा, है ना। इसका नाम है GRU। अगेन आई डोंट वांट टू गो इनटू द डिटेल्स, कोई बहुत ज्यादा डिटेल इसमें है कि नहीं। ये सिर्फ वही बात कहता है कि मैं पिछले वाले स्टेट का और अभी वाले स्टेट का जो हमारे साथ कंप्यूट करके आया है उसका एक मैं लीनियर कम्बिनेशन लूंगा। वही ये कहता है कि ऐसा करो कि पिछले वाले स्टेट का और अभी वाले का एक लीनियर कम्बिनेशन लो, और वो कम्बिनेशन में मतलब जैसे अल्फा टाइम जेड टाइम ये ले लिया 1 - जेड टाइम, अभी जो हमने टेम्परेरी कंप्यूट किया है, तो ये एक टेम्परेरी वैल्यू निकालता है कि क्या वैल्यू मेरी होनी चाहिए, और कुछ इसमें नया नहीं है। जिसे टेरेस फंक्शन से इन्होंने कंप्यूट किया कि अगली वैल्यू क्या होनी चाहिए, और उसका एक फ्रैक्शन इन्होंने लर्न किया कि किस फ्रैक्शन में पिछले वाले को और अभी वाले को मिक्स किया जाए ताकि मेरी अगली वैल्यू आ जाए। ऐसा करने से लॉजिकली लेस नंबर ऑफ कंप्यूटेशंस के साथ विद लेसर नंबर ऑफ कंप्यूटेशन वी वर एबल टू अचीव द सेम काइंड ऑफ आउटपुट। 2014 पेपर, 2014 में पेपर क्यों आया? क्योंकि बहुत दिनों तक पिछला पेपर जो है कन्फर्म था, तो कोई यूज नहीं कर रहा था। इसके बाद दूसरी टेक्निक्स है और हम इसके बारे में भी बात करेंगे। तो दिस इज कॉल्ड द GRU। ओके, मेक सेंस? एनी क्वेश्चंस? कुछ सक्सेस स्टोरीज दिखाता हूं मैं आपको। ये बहुत छोटा सा कोड है जो मेरी स्लाइड्स के ऊपर है। अगेन ये सारा स्लाइड्स राइट नाउ अवेलेबल है आपके पास इसी वक्त, ठीक है। आपको वेबसाइट पता है kty.in/ppt02.pdf डायरेक्टली अवेलेबल है, उसको लो, उसको देखो। ये सीधा सीधा कोड है, मैं इसको पाइथन का कोड है, इसको नहीं एक्सप्लेन करूंगा, बट आपको ये बता दूंगा कि ये कोड क्या करता है कि मान लो कि मैंने एक 5 डायमेंशनल वेक्टर मतलब 10 साइज का वेक्टर बनाया, ठीक है, 10 साइज का वेक्टर रैंडमली पिक किया, और इसके बाद अपने दिमाग से छुपा लिया, किसी को बताया नहीं, तीसरी वैल्यू एज एन आउटपुट देता हूँ। आप पांचवी दो, आप आठवीं दो, आप अपने मन में सोचो, आप रेंडमली 10 साइज का वेक्टर बनाओ और उसमें से हमेशा छठवीं वैल्यू या आठवीं वैल्यू या सातवीं वैल्यू निकाल के आउटपुट बना दो। अब ऐसे एक बड़ा सा डेटाबेस बना दो, देखो इस इनपुट पे ये आउटपुट, इस इनपुट पे ये आउटपुट, इस इनपुट पे ये आउटपुट, और ये मैं आपको टेबल दे दूं, मैं आपसे कहूं कि मुझे बताओ एक फंक्शन जो एक किसी नए इनपुट पे आउटपुट बता सके। आपको लगता है बना पाओगे? कैसे बनाओगे? अगर आपको पता नहीं है कि ये इनपुट आउटपुट यही है कि वो उसमें से एक नंबर उठा के बताता है, कैसे बताओगे आप? ऐसा सिस्टम कैसे बनाओगे? क्योंकि इनफिनिट तरीके हो सकते हैं ना, 10 वैल्यू मैं दे रहा हूं, उनमें से एक वैल्यू और एक वैल्यू आउटपुट है, वो उसी के अंदर भी है, तो क्या होगा? नहीं बताया ना, मुझे नहीं पता। मैं ऐसा एक बड़ा डेटाबेस बनाता हूं, कितने, एक 10,000 सैंपल, ऐसे 1000 सैंपल्स क्रिएट करता हूं और इसको सिस्टम को देता हूं एलएसटीएम को ट्रेन करने के लिए, और फिर एलएसटीएम को देकर के मैं आउटपुट पूछता हूं। ठीक है, ये उसका कोड है, बहुत ही सिंपल कोड है, अपने आप से आप लिखकर देखिएगा। इसके अंदर जो है ये 10,000 एग्जाम्पल पहले क्रिएट करता है। ठीक है, 10,000 एग्जाम्पल क्रिएट करता है, ये हमारे द्वारा लिखा गया कोड है, कोई बड़ा नहीं है, आप अपने आप से टाइप कर लेंगे, 20 लाइन का भी कोड नहीं है। और इसके बाद 100 रेंडमली जनरेट के ऊपर टेस्ट करता है और इसकी एक्यूरेसी 100% आती है ना। तो ये अपने आप जो आपने मॉडल देखा उसके अंदर ही इस तरीके से चीजें हैं कि वो अपने आप एलएसटीएम जो है हमारा अपने आप उसको कर लेता है। ये इसका डायरेक्ट कोड है, आप चला के देखिएगा। ठीक है, इंटरेस्टिंग। ये दूसरा एग्जांपल है, आई थिंक ये वेबसाइट पे आपको बहुत जल्द मिल जाएगा, शेक्सपियर लाइक टेक्स्ट। ओके, तो इसमें क्या है कि शेक्सपियर से जो भी चीजें लिखी है उनको एक ही सिंगल पीडीएफ फाइल में लिखा, 4.5 4.4 एमबी की फाइल एक फाइल में बनाया और उसको 3 लेयर के आरएनए के थ्रू, जिसमें 512 हिडन नोड्स थे, उसके ऊपर ट्रेन किया। और ट्रेन करने के बाद क्या किया, रैंडमली कुछ इसको दिया, जैसे VIOLA दिया, तो उसके बाद उसने ये जनरेट कर दिया। अब ये बकवास है, इसका मतलब शेक्सपियर जैसा कुछ नहीं है, लेकिन आप देख सकते हो कि जैसे शेक्सपियर लिखता था उसी तरीके से ये भी आउटपुट जनरेट हुआ है। आप देख रहे हो, लेकिन इसने स्टोरी टाइप का कुछ जनरेट कर दिया है। ओके, ये देखिए कितना छोटा सा, पीछे कर रहा हूं, ये छोटा सा कोड है और ये बड़े आसानी से किया जा सकता है। नेक्स्ट एग्जांपल, लेटेक्स आप जानते हैं, एक लेटेक्स एक डॉक्यूमेंट प्रोसेसिंग सिस्टम है जिसमें कुछ लिखने के लिए आप उसका कोड लिखते हो। अगर उसका कोड ले लिया गया, और एक किताब थी मैथमेटिक्स की, किसके ऊपर थी, ये यहाँ पे अवेलेबल है ये कोड। सो ऑनलाइन लेटेक्स कोड फॉर एल्जेब्रिक ज्योमेट्री बुक, एल्जेब्रिक ज्योमेट्री की बुक थी, उसके ऊपर ट्रेन किया गया, पूरा दिया गया और देखा कि वही इनपुट आउटपुट मिले। नेक्स्ट आउटपुट मतलब कैसे ट्रेन किया गया कि भाई ये दूंगा तो ये मिले, ये दूंगा तो ये मिले, ये दूंगा तो ये मिले, यूनिट को रिड्यूस किया गया, तो उससे ये जनरेट हुआ। ठीक है, अब आप इसको देख के क्या कर सकते हो, डज इट मेक एनी सेंस जो उसने लेवा लिखा है, क्या वो लेवा सच है? कोई मतलब नहीं, बस उसको मालूम है कि पहले लेवा लिखो, इसके बाद प्रूफ लिखना पड़ेगा, प्रूफ के बाद जो है यहाँ डॉट लगाना पड़ेगा जब प्रूफ खत्म हो अगला वाला, है ना। इसके बाद किस किस तरीके से फॉर्मुलेशन है, इसको आपने इटैलिक्स लिखना है, इसमें कैसे लिखना है, देखिए तो आप जनरेट कर सकते हो। काफी स्ट्रक्चर वो पकड़ सकता है। अगेन ये एग्जांपल है जो लिनक्स के सारे जो सोर्स कोड है उसके ऊपर ट्रेन किया गया, लिनक्स का पूरा सोर्स कोड लेकर के उसके ऊपर आर्गुमेंट ट्रेन किया गया। इसके बाद वो रैंडमली कुछ जनरेट करता है, देखिए ये चीज उसने जनरेट करी। क्या आप कोड रन करेंगे? नहीं, कंप्यूटर हैक कर जाएगा, कुछ होगा, मुझे पता नहीं क्या करेगा। लेकिन अगर आप इसको देखें तो आप समझ पाएंगे कि बिल्कुल सही तरीके से ऊपर कमेंट लिखता है जैसे उसकी पूरी फाइलों में लिखा हुआ है। स्टैटिक वाइड एक्शन, ब्रैकेट शुरू होता है बंद होता है, सेमीकोलन शुरू होता है बंद होता है, कुछ ऐसे लिखने वाला लाइन, देखिए तो कोड जैसा लग रहा है, क्या कर रहा है पता नहीं, पूरी तरीके से बोगस कोड है। दो तीन चीजें इसको नहीं समझ में आई कि कोई भी वेरिएबल जो हम यहाँ यूज करते हैं उसको ऊपर डिफाइन किया जाना चाहिए, उसके अलावा ज्यादातर चीजें इसकी सही है, कोड जैसा लग रहा है। ये है आरएन की पावर। ये रिसेंट, बहुत रिसेंट तो नहीं है लेकिन CBPR 2015 का पेपर है, उसी ली था जिसने एक बहुत बड़ा डेटाबेस दिया और उसके बाद सारी चीजें शुरू हुई। उनका पेपर है करपात्री, जो आपको मालूम होना चाहिए एंड्रीज, और ये लोग जो है हमारे टॉप रिसर्चर हैं जो ये है। तो इन लोगों ने ये मॉडल किया कि आरएनए में जो पहली इनपुट है ना, जो फर्स्ट इनपुट है, वो मैं क्या दूं, क्योंकि जब दूसरा इनपुट है तो पिछले वाले का कंप्यूट होके आया है। पहले वाला इनपुट क्या है, फर्स्ट इनपुट व्हाट शुड आई डू, इट ऑलवेज रिमेंस अ क्वेश्चन। ओके, तो उन्होंने कहा कि मान लो आपके पास एक इमेज है, आप उस पर एक सीएनएन लगाया, आपने सीएनएन आर्किटेक्चर लगाया और उसके बाद जो है यहाँ से उसका फीचर आगे क्लासिफिकेशन किया और ट्रेन कर लिया। ट्रेन करने के बाद की सही क्लासिफिकेशन वो देने लगा। उसके बाद आप इमेज डालो और 20 से काट लो, मतलब आगे वाली चीजें जो थी वो हटा दो, 20 का जो आउटपुट था वही आउटपुट लेकर के यहाँ पे दे दो। एक तरीके से ये जो बीच वाली चीज है इसका फीचर है। ये चीज जब आप इसमें इनपुट कर देते हो, यानी आप जो फार्मूला था उसके अंदर जो यहाँ पे आप कंप्यूट कर रहे थे यूटी डब्ल्यूटी, उसके अंदर आप जेटी इस वाली की वैल्यू को भी आप एक बार उसके अंदर डाल दो, बी मल्टीप्लाइड बी को आप जेट ट्रांसफॉर्म पिछले वाले के साथ इसकी वैल्यू के साथ भी हर जगह पे आप उसको डाल दो स्टेट में। तो फायदा क्या होगा कि अब जो कंप्यूटेशन करेगा वो इससे भी कुछ लर्न कर लेगा। और इंटरेस्टिंगली आप देखो कि ये फोटो देने के बाद जब आप स्टार्ट कहते हैं तो स्ट्रा कहता है, स्ट्रा फिर हेड फिर स्ट्रा हेड, उसने बताया कि यहाँ पे स्ट्रा हेड। ये आर्किटेक्चर है, क्योंकि कोई बड़ी बात नहीं है। आप देख रहे हो कन्वोल्यूशनल मैक्स पूलिंग, कन्वोल्यूशन मैक्स पूलिंग, एंड नथिंग फैंसी इन दिस। पीछे निकाल के तो इसने इस तरीके से इसको बार बार आपको चेंज करना पड़ता है। इसे हाइपर पैरामीटर ट्यूनिंग करते हैं, इसे कोई बहुत ज्यादा स्टैंडर्ड तरीका नहीं है, लेकिन ये बहुत सारे एक्सपेरिमेंट के बाद आप बताते हैं इस एक्सपेरिमेंट से मेरा रिजल्ट अच्छा आने लगा और ये चीज आप रिपोर्ट करते हैं। सो यूजिंग दिस वैल्यू यू कैन डू a kind of image captioning also. Using same kind of structure you can do image captioning. So that's all for today, this session. Thank you very much for your attention. Hope you enjoyed something and learned something interesting. Thank you. Any questions? First from the online participants. सर ने जैसा कि बताया है, मैं थोड़ा जल्दी छोड़ दिया आपको 12:40 से अभी, तो हम लोग जल्दी से लंच करेंगे और लंच के बाद हम लोग 45 पे शुरू करते हैं, 1:45 पे अगला सेशन शुरू कर देंगे, क्योंकि आदित्य का सेशन 4 बजे से है, तो उसमें थोड़ा एक्टिवली पार्टिसिपेट कीजिए। इट इज अगेन गोइंग टू बी वेरी इंटरेस्टिंग सेशन एंड ही विल बी टॉकिंग अबाउट व्हाट LLMs, लार्ज लैंग्वेज मॉडल्स। ओके, सो विद दैट थैंक यू एवरीबॉडी। कोई सवाल हो बताओ मुझे। Any questions? Location?
Last version एक नया that is given as an input to the again another neuron.
Yes.
But in the final neuron, the output was not transferred to the final output.
नहीं, क्योंकि हमने फाइनल में तो अभी लास्ट वाला तो इनपुट है ही है मेरे पास, मैं उसके आधार पे कंप्यूट करूंगा ना, और पिछले वाले सारे आ ही गए, उनका डाइजेस्ट आ गया एक तरीके से पिछली वाली वैल्यू के साथ। अब वो फ्यूचर को रिप्रेजेंट करता है ना, फ्यूचर वाली जगह पे फ्यूचर में क्या होगा नहीं पता मुझे, अभी राइट नाउ नहीं होनी चाहिए। वो तब यूज होगा उन केसेस में जहां पे हम लैंग्वेज ट्रांसलेशन कर रहे हैं ना। अभी इसके बाद मैं इनपुट लेना बंद कर दूंगा तब भी वो आउटपुट देता रहेगा, ऐसे केसेस में क्यों यूज होगा। ठीक है, डन। थैंक यू वंस अगेन, थैंक यू। And I think now we would break, and so they can leave the room.
So any question from the online participants? At least ask one question so that we can understand you are also attending the session. No question from the online participants?
So Mayank Taneja, are you there? Vijay?
Mayank Taneja, are you there?
हाँ मैं बताओ मुझे you have any question so I have a question from you so in LSTM and GRU which has a less number of parameters
So GRU, sir.
thank you so I just wanted to announce one more thing that you will be shortly getting the link for your test. So every day you have to provide for the first day also you have to give the answer. There will be a small quiz. Okay? So you have to give a test so that we can compile the scores and then people who are getting more than some threshold scores, they will be getting the certificate only. Okay, not everybody. Is it fine? Yeah. All right. Thank you. Thank you.
Small information for online participants. The session will get started at 1:45 in the lab itself. So, you can have a lunch break now.